So in this video we're going to talk about state function and path function. So state function is a measurable property of system whose value depend on the current state of system. So that is independent how the state has been reached. So it depend on the current and state of the system. It doesn't depend how the state has been reached. The value of a state function does not depend on the path of the process. It doesn't depend on the path of the process means how system gets from one state to another. It doesn't depend how it is going from one step to another, how long or how short the path has been taken, but it depends on the how the path, what is the final and initial position. So change in a state function and fixed value if we define its initial and final state. So example, internal energy. So whatever is the change is that only depends on the final and the initial value. It doesn't depend how the state, how the process has been gone. So let's consider a curve, PV curve. So like we have here the internal energy U1 and here internal energy is U2. Now we have three different paths. First it is going from this path, second it is going by this path, and third time it is going by this path. So these three paths it is followed. So here the delta U, so here it doesn't depend whatever the path is followed. So change in internal energy will be U2 minus U1. So it doesn't depend if it is 1, 2, 3. So change in internal energy in same of first process equals to second process equals to third process. So when we talk about the path function, so path function are not measurable property of a system. So we cannot measure the property of the system, means heat and work are the path function. The value of path function does not depend on initial and final state, but also depend on the path of the process, how process is carried out and vary accordingly. Example, heat and work done. So again if we consider we have a PV curve and now we have three different now position. Now it is going from 1 to going to state 2. So it is the first process, it is the second path, it is the third process. So can we say like the 1 will be equals to 2 equals to 3, but that is not equals because this is a path function. So in the path function we talk about the work done, so that will be equals to the area under the curve. So we will be knowing that W3 will be 1 will be higher than 2 then 3 because we will integrate it and we will find that the value is equals to the area under the curve in case of work done. So that we learn later, but now we have to see that we have taken three different paths and the work done will not be equals to, because it is a path function. So that doesn't depend on the initial and final state, but depend on the path of the process, how the process is carried out and vary accordingly. So if we see we have only two types of path function, heat and work are only two path function. So now let's look what are the exact and inexact differential. So if we say like if we want to integrate the del du, which we know it is a state function and going from initial to final. So here that will be coming out to be delta u, where delta u will be equals to u final minus u initial. That has the fixed value when it is going, so that is the fixed value. But when we will integrate w initial to final, if we integrate dw, that will not be equals to delta w and that will not be equals to w final minus w initial. Whenever we are integrating the path function and that is going initial to final through the process delta w, so that we know it is a path function. So in that case it will be equals to the w. And similarly when we integrate any another one more path function I initial to final and it is a path function again, so dq if we try to integrate, so it will be forming q. So we know that it is why it is forming q and w, because in that case it will be area under the curve. In that case it is area under the curve. So now that's why it is coming out to be w. We will getting the exact value. Now if you look at the definition again, are not measurable property of the system, heat and so path function does not depend on initial and final state. So here if we, that's how the difference between the integrating state function and a path function. Whenever we will be integrating the state function, the value we will be getting equals to delta u, that is equals to final minus initial, that is the fixed value. But whenever we will be integrating delta w, that will be not a value equal because it will depend on the path taken path taken by the function, that will depend on that value. So it will, when we are, whether we see work or we see heat, we will not getting the fixed value, we will getting a different value because it is depending on their path. So that's how we see different types of function in thermodynamics.